Funny channels are called that because they leak both sodium and potassium at different times. These channels flow in what's called the pacemaker current because they set the cell's pacemaker activity and are the whole reason the heart has inherent automaticity. What the ECG signals mean. Before we talk about what the ECG signals mean on a small scale, you should review what happens as the heart's electrical system functions in real time. As you know, in a healthy person, the SA node starts initiating a heartbeat because it has the fastest rate of automaticity. It sends that signal across the atria, signaling these muscles to contract. As you can imagine, this starts blood flowing through the ventricles as they fill during diastole. The electrical signal also reaches the AV node. This node is critical because there is a pause or delay in the passage onward of the electrical signal here. If you know how the heart works, you'll see why this is important. If the signal reached the ventricles too fast, they would contract before they had a chance to fill up with blood. The whole thing would be out of sync. The resting period or delay in the AV node helps allow for this filling up of the ventricles, lasting about 120 milliseconds. After the AV node, the signal goes down the bundle of His and splits into the left and right bundle branches. Then they travel in a wide array around the ventricles through the Purkinje fibers. As you can see, these will cause the ventricles to squeeze upward like a tube of toothpaste to send blood up to the semilunar valves and outside the heart itself. See how coordinated the whole thing is? It is truly a symphony of electrical activity and contractions that allow blood to effectively flow through the heart and eject from it. Did you know? Artificial pacemakers are used to keep the heart going at a regular pace when it can't do it by itself. A wire is passed into the heart through the veins leading to the organ, then inserted into the heart muscle. It paces the heart by sending regular signals for it to contract. It works best for slow heartbeats or bradycardia, and is harder to be effective for fast heartbeats or tachycardia because the pacemaker has difficulty interrupting a faster rate than its own. Remember that the fastest pacemaker to the heart wins and therefore sets the overall heart rate. Now we get to the interesting stuff about what happens to the heart's electrical activity during a single beat. It is the electrical activity you'll see every time you read an ECG, and we will talk a lot more about this in a minute. But first, here is what the typical electrical activity looks like in a single heartbeat. The paper used on an ECG is designed so that each tiny 1 mm per square in width equals 0.004 seconds and each 1 mm in height stands for 0.01 millivolts in electrical activity. This means that the strip outputs at a pace of 25 mm per second and that 10 mm 1 centimeter equals 1 millivolt. The beat starts with a P wave, representing the electrical activity you'll see when the atria depolarize or begin to contract. The space between the beginning of the P wave and the start of the next wave, the R wave, is called the PR interval. This represents atrial depolarization to the beginning of ventricular depolarization or contraction. Within there is an even smaller part called the PR segment, which is the space between the end of the P wave and the start of the R wave. The QRS complex is next. It starts with a slight downward deflection called the Q wave, then peaks upward to make a deflection called the R wave. Then it drops sharply down to the S wave before moving back up to the baseline. The width of the QRS complex is important in knowing if the AV node is working properly. It should be relatively narrow. It reflects the time of ventricular depolarization. Hidden inside the QRS complex is the repolarization wave. This means the atria are returning to a resting state wave of the atria. You can't actually see it because the QRS complex hides it. After the QRS complex is the ST segment between the S peak and the beginning of the T wave. The ST interval isn't as important clinically, but it is the interval between the S peak and the end of the T wave. The T wave represents the time of ventricular repolarization or the ventricles returning to a state of rest. Not everyone has a U wave. It is usually an abnormal finding in the heart. It is a tiny wave that is thought to occur when the Purkinje fibers depolarize, but really no one knows this for sure. The next image shows what is happening in the cardiac cycle during a single cycle. The artificial beginning of the cycle is during both atrial diastole and ventricular diastole. The P wave is the electrical beginning of the cardiac cycle. Note that the start of both the atria and ventricles systole happens essentially at the peak of the P wave and QRS complex respectively. This is because these parts of the heart muscle need the electrical impulse first before they can contract.